All right, so welcome to more or less the last thing that keeps you from having lunch. This is probably the only talk that has some AI content. Okay, so, what's going on? Oh, screensaver. What? Yeah. Okay, so the timeout is really short. All right, so I want to talk a little bit about what are called Nodeworld. There's like three goals to this talk. One is to add a little bit of technical detail to a previous talk that might or might not be similar to what I'm talking about, the Clario project, right? So some of this, or actually this is the language architecture from the Clario project. Second thing is to maybe give you a couple of ideas how far you can push this notion of doing everything with kind of languages and doing that at various meta levels, you'll see. And the third thing is, so one of my roles in daily work is as a evangelist slash propagandist relative to DSLs, trying to convince organizations to use the approach. And sometimes, as soon as you use the word language or model or formal model or DSL, you run into a wall because it's for some reason negatively connotated. And so maybe talking about nodes and doing everything with nodes and using this well-known principle of turtles all the way down, meaning doing everything in the same way, is perhaps a better way of communicating the idea. I don't know. It's an idea. Anyway, so there's a whole bunch of all turtle systems in history. The Unix shell, right? The turtles are text files or files in general, processes and pipes, Smalltalk. Everything is an object, including code, right? So you can do a lot of reflective stuff in Smalltalk systems. Lisp also, everything is values, lists, or functions, well, and macros. And then MPS, right? MPS is hopefully not history, but it's certainly one of these systems where everything is kind of made from the same stuff. And so because everything is the same, you need only very few generic tools to do, quote, everything, and to extend the thing and the meta thing and all of that. So that's what I want to talk about a little bit. And this turtles all the way down, I did a lot of extensive research where this comes from, meaning I went to Wikipedia. And it actually means something slightly different than what we. So in computer science, this is basically this idea that, like, you know, software is based on software is based on software is based on software until theoretically infinitely, and at some end there's the processor. But you can read this for yourself. It has a slightly more something to do with flat Earth. So whatever. The rest of the talk is basically a huge diagram with lots of different kinds of arrows. And maybe it's confusing, then it was a bad choice. Maybe it gives you a big picture and helps you understand things. So we built this DSL, right? And like most DSLs, you can split the language, if you will, into domain-specific structures. They could be, for example, forms and protocols and study events, right? Perhaps. And domain-specific expressions, right? For example, ways of calculating the average blood pressure based on the last 10 form submissions from the last 7 visits within the last 2 weeks, right? This is the kind of stuff you need to do in these trials. Of course, as every reasonably and good and well-behaving DSL, it's built on top of kernel F. So you have these kind of 3 levels, and the kernel F part is not domain-specific. That's the whole point, right? It's this base language. You've probably all heard about it. And the domain structures, they are in most DSLs, certainly in this one, you can separate them into different viewpoints, right? Different aspects, different parts of the system. In this particular example, as you've seen in the screenshots in the previous talk this morning, it's things like the forms, the study definitions, workflows. We didn't show workflows, stuff like that. And you can almost see the languages or the parts of the overall DSL for these separate aspects as their own little sub-language. It's almost like a philosophical discussion whether you say it's a set of languages that collaborate to describe studies or it's one DSL that has different aspects. It doesn't matter. So, of course, there is also domain-specific tests. So we have implemented a testing language to be able to verify that these protocols with their structures, behaviors, and all of this work correctly based on the usual unit testing approach. I mean, so far, so normal. I once wrote a paper where I kind of called this stuff a funclerative DSL, kind of a mix between functional for the expression part and declarative for the studies and high-level behaviors, right? And I think for me personally, that is certainly a best practice about how I build DSLs, but this is really, I almost assume this as the starting point for the rest of the discussion. This is just how you do it, in my opinion. So what else did we do? Well, first of all, of course, we have the one meta level down, we have the models, right? So we have the models that capture the subject matter expressed with these languages plus tests for them, right? So obviously also nothing new here. But then we have implemented an issues language. So the issues language is basically a way of capturing issues like you would do in an issue tracker. But we capture them directly in the model with a separate language. It's really not part of the DSL in some sense. It's a bit orthogonal, right? Or I shouldn't walk there. I have to use the pointer thing. I wonder how this actually works, that this moves my mouse pointer, even though, or whatever. Okay, so, turtles, yes, turtle somewhere. So, and the point is that you can, that the issues live in the same model as the subject matter. So, for example, if you branch your model, the issues are branched with it, right? So you can do the issue management along with your actual, if you will, programming or modeling. And of course, you can attach the issues to nodes, right? So you can literally select a node anywhere in your DSL up there, Alt-Enter, attach issue, you get an annotation on it that points to the issue, and the issue has a life cycle with, new, resolved, blah, blah, blah. And so it's all kind of in one thing. So the ability that you can do this kind of orthogonal thing within your models in Git, in the same user experience, is an example of this everything turtles, right? And it's useful. There's, of course, also drawbacks. I mean, you don't want to rebuild, whatever your favorite issue tracker is. This needs to be reasonably simple in terms of what you support here. But the power it gets is through the close association with your subject matter models. What? I moved, I'm sorry. Yeah. So then these models that you create here, they are generated. So these double arrows here, this means generation or transformation. The blue G means there are generators. This whole DSL I created here, right? And so it generates to existing runtimes, multiple ones at least, potentially. And this is also where it leaves Nodeworld, right? This execution down here is no longer nodes, right? So, okay, that's just the reality. At some point, you have to run the thing in existing infrastructures. You don't want to build an interpreter that moves node instances around at runtime of your production system. It would be too slow and it would be bound to MPS. That's just pragmatically impossible. But there's more. There's, of course, the interpreter, right, which runs the tests. That's the usual kernel F interpreter, which we have, of course, extended with all the domain-specific stuff. There is also an interactive UI-based simulator, as I mentioned this morning. And as I said, these are also a little bit kind of almost at the edge of the turtle space, because the interpreter for kernel F, the one we use, does not work by representing execution state with MPS models, right? It does that by executing Java, which is, it has drawbacks. For example, if you have an interpreter that, as a consequence of its execution, produces something that you then want to be able to represent in your model, you can't directly do that, right? Because it doesn't produce a set of nodes, a tree, as the final result of the execution. And that breaks the everything turtles. So certainly an experiment would be, for somebody, to implement an interpreter like that does everything based on nodes. And ideally do that in a way that's not even slower than the current interpreter implementation, because one thing this isn't is fast, right? As we know, I mean, there was a talk by Nico probably at the last MPS meetup about how this could be accelerated. So the interpreter works well for smallish use cases. It doesn't really scale to huge stuff. Anyway, and I suspect if we do everything with nodes and turtles, then it's going to become slower. Turtles. Yes. So, but there's more. Because I'm going to say that 5 more times today. There are, of course, the node tests, right? The usual. Right. Apparently, I don't get how I have to move this. There are node tests. You know them from MPS, right? These are these nodes test cases where you can write, for example, checks of type system rules, validation rules, code completion checks, and stuff like that. So, and of course, I mean, it's totally obvious to all of you, but these are also just nodes, the tests, right? They are like one meta level higher because you look at your code as an object instead of as the running thing, but it's also turtles. And there are also editor tests. Now, these things, because there are turtles, they can be extended. And that's what we did in this project. We were asked/forced at some point to have the tests use BDD style syntax. So we had to put a, given something when actually nothing happens, that was then this is the outcome. So you can extend the language to build your own dialect of how you represent the test cases. We have extended the testing language to be able to test UI actions. Intentions tests are already there. We have built certain utilities for testing code completion, stuff like that. And of course, that's only possible because, again, the tests are also nodes. And because you extend them by defining more nodes and concepts, the user doesn't feel a break, right? It's everything the same. And then, of course, we connected this to the ALM system. In this case, it was Polarian, but it doesn't matter. So we basically attached annotations to all of these tests to then connect them to Polarian issues. At one point, we removed this again because the process changed. But the ability to use annotations on anything to, in this case, leave the Nodeworld to point to an external tool is, again, nice because it works everywhere. We also, of course, attached the same kind of pointers to the executable tests, right? These scripted tests of protocols that I showed this morning, where you can say on this day, the user takes a pill, and then 3 days later, we check that the fever is lower, stuff like that. And so basically everything, both the tests of the language and the tests of the actual behavior, which are implicitly also tests of the language, right? Because, I mean, okay, different story. Everything is connected to the same set of requirements, kind of in Polarian. We also implemented a dead code detector. Just implement a piece of meta-level code that finds all behavior methods that are not called from anywhere. That's like 10 lines, base language, right? Find usages facade, you're done. And again, you can do this because everything is the same, right? So if you try to do that, I mean, specifically that code detection is available in any other language already out of the box. But if you did kind of custom analysis of your implementation in any non-MPS environment, it would be a huge deal because at this point now you'd have to, find ways of accessing IntelliJ's internal representation of code or whatever you would have to do, right? Or use a style checker tool that has an API and program against that. Here, it's just a few lines of base language code, which you, of course, already know. So that's the kind of current world. We have the domain world, right? Where we have our DSL with the issues and the simulator and the interpreter and the generators to the existing runtimes. Plus, we call it the spec world, where we do everything that is required for essentially quality assuring the language definition itself. This is quality assuring the subject matter, but this stuff is kind of quality assuring the language itself. This leads me to a quick commercial break. Because you might ask yourself, when I want to build this domain world, how the hell do I know what goes into the domain? How do you find out? Turns out I wrote a book recently about domain analysis. It has this great title, which my marketing department came up with. It basically tries to structure this whole process of understanding the domain, finding out from users what a language should do, and then verifying that. It's a book that has nothing to do with DSLs. It says this in the first 10 pages or so, probably 5 times, because I didn't want to restrict the readership. But of course, here I can admit, it's basically about how do you find out what goes into a DSL. But don't tell anybody. And also, yes, I know that's wrong. Got to fix that in the slides you'll get for download. So back to programming in the literal sense. So we have the domain world and the spec world. These are 2 parts of the node world in this kind of project. There is a third world, and it's a document world. That's why I said this morning, somebody over there asked the question, right, how we do with the document stuff. So now you'll find out. So there are more languages. There is the document language, which has fancy abstractions like section, paragraph, table, link, stuff like that, right? Link, I mean, reference, cross-reference in the document. It's not fancy. But what we also have here, somebody was asking this morning in the context of the talk from Tobias, how do you test the documents, right? What we do is we generate documents in this document language. In other words, we represent them as MPS models or nodes. And then we have a language, it's an extension of the nodes testing language in MPS, where we can basically kind of imagine it as a document language specific XPath kind of thing, where you can say in the third section, the second subsection should contain a table that has the following shape, and in the third row, 5th column, there needs to be something that corresponds to the name of this event in the domain model, right? You can either literally use regular expressions to match strings or stuff, but you can also connect it back to the source model. And so this way, we, or somebody actually, had to, or was allowed or able to write lots of tests to verify that the generated document on the level of this node structure is correctly representing the actual model. And then, of course, behind that, this should hopefully be the next slide, no, more or less, there is an HTML generator that outputs this to, HTML, so we can view it in the browser. We embedded the browser in MPS, right, like we've seen earlier yesterday, and so you can directly, view the document in MPS. Go back here, because the document language is just another language, you can build kind of utilities on that. For example, we have a table of contents generator that works generically. I mean, again, not rocket science, but all enabled by nodes everywhere. We have a document differ. We need that because when we generate one of these protocol specifications for the next version of the protocol, the document needs to contain a description of what has changed compared to the previous version of the document, of the release for the document for the previous release of the protocol. And so what we do is we keep around the MPS, the node instances, the models that represent the document for the previous release. Then we run the differ, and the differ produces, surprise, surprise, more document, right? It produces paragraphs and tables that describe what has changed, and we append that to the document. So we have a generic document differ, which as a result produces document contents that you put in the new document. You get the story, right? And again, it works completely generically because, it's all turtles. So then how do we use the document stuff? Well, first of all, like we've said this morning, we generate from the formal executable domain-specific description of a protocol, we generate a prose document, which I always find a little bit, we already have the executable interactive tool-based way of understanding the protocol, but now we have to express it as text. It's a bit frustrating, but I understand why it's necessary in the overall common process, right? There's people who use this to customize some of the implementation, and there are also, depending on how exactly you see this is sometimes, or is given to like the end customers of these protocols who don't necessarily want to play with MPS to understand what they just bought, right? So makes sense. Anyway, so when we generate this document, we do a more or less model-to-model transformation to this language. We do the talk, we do the diff to get the changes to the previous version, and then we generate the HTML. We have more use cases. For example, we generate a glossary. So in order to communicate how the language works to various different stakeholders, we generate a glossary that has the name of the concept, it has the short description, right, the one that you enter in MPS. It also has, we run the glossary from a certain model, and then we grab instances of the concept we're documenting and screenshot that node in order to put that as an example into the glossary, so that the glossary contains example code with a link to MPS to actually see how it runs. Again, all nodes. We also generate a test report because, medical domain, everything needs to be proven, quality assured, and documented to death. So from all these different domain-specific, executable, and also language tests, we generate test reports by also generating down to the document language. And then we have a charts language, with which we can render these chart-based execution diagrams of how the protocol runs. And of course, we have a chart test language where we can write tests that verify that on day 7, there's a blue box in the chart because that means something is ready, right, in terms of the workflow. And of course, these charts are embeddable into the documents. So the documents can contain charts that then are generated to HTML. So what's that last arrow? Oh, yeah, okay, whatever. There's also a plant UML generator for generating language structure and embedding some of the workflow diagrams. So as you can see, there's a whole complicated is too negative, flexible, cool, multifaceted world, but everything is nodes. And again, for most of you, at least if you're an experienced MPS user, this is kind of boring because, yeah, sure, that's the point. But many users or people whom we want to convince that that's the way to build software don't get that. They don't see that building something like that is 2 hours of work, not 2 weeks or months or stuff like that. So that's the node world. What's the point? First of all, why does MPS have the best turtles, right? It has the best turtles because they have lots of tools under their shells, right? They're kind of very powerful robot turtles that can do all these cool things. In other words, you have notations, editors, transformations, interpretations, and custom actions. This was customizations before editing error. And so I already talked about the things that aren't turtles, so we can't fly, right? So certain things don't work. So this brings me to the end, out of time anyway. So wrap up. The point is that if everything's the same and every meta level is implemented with the same stuff, it's easy to build stuff that does things with stuff, right? So you treat code as data. And because in MPS, you could argue in an object-oriented system, it's the same, right? Everything is objects. But you don't have a way of treating the program itself in this way, right? Source code in a Java IDE isn't objects in the classical sense. Sure, there's an API for that, but it's not the same thing. In Smalltalk it is, but Smalltalk has the drawback that you can't you don't have the ability to define editors, right? And refactorings and stuff like that, because your IDE is again different. So long story short, I think we should consider selling MPS and similar systems not by using all this fancy language model stuff, because unless you're very lucky with your customers, it scares people away. So maybe drawing analogies to things like Unix shells, which everybody knows, I was going to say very flexible but impossible to use, so it fits well, right? No, I'm serious. We should explore other ways of explaining what these systems are doing, and maybe this node perspective can be an inspiration there. All right, so that's it. Questions?
Maybe I already said it, but so if you had to give a definition for node to these people, what would the definition of a node be?
That's a good question, right? The point is that it's a thing that is instantiatable and that your tool knows about, right? I think the key to MPS's success is that IDE tool and code are not separate, right? And so that's the difference to an object everything system. The objects only exist when you run your code, when you run the program. In MPS, nodes exist while you work on them. So I would say it's kind of objects, but statically, and you can define, I mean, said it before. It's not a great concise definition. I haven't thought about it.
Markus, in Smalltalk, you can see the ID itself as a turtle, as an object. So this moldable development.
Yeah.
I think this would be very cool here as well.
True, if MPS itself were made from nodes, but I'm a little bit skeptical there. I mean, to some degree it is, right? Some parts of MPS are models and accessible to this approach, but I worked for Intentional Software in the early 2000s for not too long. And they spent literally months trying to represent the IDE window as, they called it differently, but essentially nodes. And they re-implemented the Windows windowing system with this. Turns out they kind of forgot the important things in the meantime because they got stuck for months and months and months doing that stuff. So maybe from a pragmatic perspective, it's better not to do what you're suggesting. Perhaps, I don't know. But in principle, I agree. Would be nice.
A lot of menus and tool windows and also editor cells and this kind of stuff. Actually, they are quite close to.
If you speak a little quieter, I can't hear anything anymore.
Yeah. So I meant that the menus and you can do it through or just parts of that, and that would be cool as well.
Yeah.
I'm not so sure this approach with everything represented as node in an IDE works. Eclipse 4 tried this, right? They had an internal, they represented the state of the complete IDE as an EMF model, and it was live wired. So if you change the EMF model, it would live change the tool windows and whatever you had. I have never seen any usage of it outside the people who implemented it for demonstration.
Yeah.
So I agree from a principle point of view, but it seems the practical use cases are not that much.
Sometimes they only appear, these use cases, once you actually have it and you know, play with it. But I tend to agree.
A more practical question. Did you reuse the embedded doc language or did you came up? Okay. So you implemented from scratch something customer specific?
Yep.
Okay. Do you want to elaborate?
I would fear you would ask why, yes. I don't remember. It kind of stumbled into it, you know. Okay. It was small at the beginning. We didn't need much. So let's just build it ourselves. We don't have the dependencies, blah, blah, blah. Then it became bigger. So yeah, no good reason.
Okay, because there was already a HTML generator.
Yeah.
Okay.
Yes.
Maybe I didn't get it, or if I missed it. Are these generator outputs for the documentation the only outputs, or do you have any other generators in place? Because maybe I'm living in my company bubble, but I'm not sure if.
So the output is basically HTML, which we then do some stuff to also make it a PDF.
Yeah.
Alternatively, we could directly generate the PDF, right? We didn't do that so far, at least. And so that's the, if you will, only output, plus of course these transformations that enhance the document itself.
So with your matches, you basically check.
Oh, with the matchers. Yes, we check that this transformation is correct.
Yeah. Okay. And the content of the HTML, how do you check if this is correct?
We assume, because it's a usual argument, right? This generator is simple.
Yeah.
So you can quality assure it by Stichprobe. What's the
Some
English
kind of baseline test?
No, I mean, seriously, the reason why the argument I was just making isn't crazy is because this language is relatively small and this transformation is actually relatively straightforward, and because all kinds of different things are represented with the same few document language concepts, you will find errors in this step quickly, and it is feasible to do that manually.
Okay.
Right? And if you don't like that, you can always do more by writing a bunch of manual, let's parse the HTML and see if it fits kind of generators, or reload that back, but we didn't do that, but you could.
Yeah.
I mean, if this were, I guess, nuclear power plants instead of
hard
just humans, maybe, I don't know. It depends what's your risk assumption and whether that's good enough.
If you spend tests for that, it's also hard to maintain.
Yeah.
If something changes in the template.
Oh, that's already a nightmare, right? Yeah. So one thing, for example, we learned, it's not that the testing community hadn't known that before, but we suffered from it, is you really want to make sure that your tests are minimal, in the sense that you don't accidentally test non-essential stuff in every test case. Because when you change something about the non-essential stuff, for example, layout that has structural consequences on that level, lots of your test breaks, even though there isn't really a semantic change.
Yeah. Thank you.
All right. Thanks.